Okay, so today we're going to start chapter 7 and we're going to cover section 1 today. And we're going to learn about angles of polygons. So first of all, we need to review what the parts of a polygon are. So each segment that forms a polygon is called the side of the polygon. The common endpoints of two sides is called the vertex of the polygon. And then a segment that connects any two non-consecutive vertices is called a diagonal. Okay, so if you saw the word two consecutive sides, two consecutive connections of vertices, that forms a side. So for example, consecutive means like in order. Consecutive integers are like 1, 2, 3, 4. So consecutive vertices would be like E and then going to the D. And when you connect those two vertices, that forms a side. But if you connect two non-consecutive vertices, like I could draw in a diagonal, here's going from E, and I can't draw it to A or D because that would make a side, but I could draw one to B because that's not right next to it or consecutive, and that forms a diagonal. So I could draw a bunch of diagonals throughout here. I could go from A to D, I could go from C to E. These are all diagonals when you connect two vertices that are non-consecutive. The next are the names for specific polygons. And this was actually, I think, in the same notes that we did, I think from section 1.6 or something from chapter 1. So 3-sided polygon is called a triangle, 4 sides quadrilateral, 5 pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 is a decagon, and then 12 is a dodecagon. Anything larger than that, like let's say you have 50 sides, you would just put the 50 and then you would put GON. So these are the special names that you should be familiar with when we're doing any of these problems. Now, this chapter 7 is mostly going to just deal with quadrilaterals. But again, this first section is going to talk about all different types of polygons. But after this section, it's going to be focusing on only 4-sided figures on quadrilaterals. To find the sum of the interior angle measures of a convex polygon, remember convex, we learned back in chapter 1, where all of the vertices are pointing out, nothing's caving in. You're going to draw in all possible diagonals from one vertex of the polygon. So we're not going to draw in all the diagonals from every vertex. You pick one, and then you draw in all the diagonals from that one vertex. This is going to create a set of triangles. Remember that the sum of the measures of a triangle equals 180. So in here, what you're going to do is the measures of all the triangles is going to equal the sum of the angle measures of the particular polygon. So for example, notice for my triangle, I can't draw any diagonals there because there aren't any two non-consecutive vertices that I could connect. So we know that it's only forming one triangle, so the sum of these 3 angles of this triangle is 180 degrees. For quadrilaterals, notice if we go ahead and let's say we put in some letters here, A, B, C, D, and I pick one of the vertices, so here they chose D, and then you try to draw in as many diagonals as possible. This one you can only form one diagonal, which has now made 2 triangles. And again, if you know that each triangle, all 3 angles add up to be 180, I've got 2 triangles here. So the sum of all 4 angles of the quadrilateral is going to be 360. And then for the pentagon, if you start from only this vertice, I can draw a diagonal here and then to this non-consecutive. making 1, 2, 3 triangles. So I can draw in 2 diagonals here and form 3 triangles. And again, you would do 180 times 3, and that's going to give you 540. So the 5 angles of a pentagon are going to add up to be 540. Now, I'm going to teach you a formula so you don't have to do this. You're not going to have to draw the figure and draw in the diagonals. I am going to teach you a formula that is going to simplify this process. So, yes. Yes. So here, again, what we just did, notice the number of sides in a triangle is 3. We know it forms 1 triangle, so that sum of those 3 angles of the triangle is 180. Quadrilateral, 4 sides, 2 triangles are formed when I draw that diagonal, and I get 360. The whole purpose of this chart is to show the pattern. All you need to do is memorize this formula. In this formula, n minus 2 times 180, this gives you the sum of all of the angles of the polygon, where n is going to be the number of sides in your polygon. So all you do is memorize that formula, and then you can figure out what all of the angles of any polygon will add up to be. So again, if we try this formula on the triangle, a triangle has 3 sides, so that's what our n equals. So if I use the formula n minus 2 times 180, 3 minus 2 times 180, 3 minus 2 is 1, 1 times 180 is 180. So the 3 angles of a triangle add up to be 180 degrees. And I can use this formula for any polygon. Let's say, again, it's that pentagon. Pentagon, you need to memorize, has 5 sides, so n equals 5. So I'm going to do n minus 2, so 5 minus 2 times 180. I get 3 times 180, and again multiply that, and I get 540. So all 5 angles of my pentagon add up to be 540. The formula is always minus 2 from the number of sides. Once you get that answer, times it by 180. So next slide actually has this formula now officially presented as a theorem. So here, the polygon interior angles theorem is just n minus 2 times 180. And that will give you what all of the angles add up to be. The corollary to that theorem, this one tells us what the sum of the measures of a quadrilateral would be. And again, you could do the formula, but because this chapter is all about quadrilaterals, always know that any 4-sided figure, the 4 angles will always add up to be 360. So just like before you memorized that the triangle adds to 180, now you're going to memorize that the quadrilateral is always 360. And here it is officially presented as a corollary. Pretty good? Next slide, we also talked about in chapter 1. We talked about equilateral, equiangular, and the word regular. Whenever you see the word equilateral, that means all sides in your polygon are equal. They're all congruent. When you see equiangular, think about it being like equal and angle. All angles are congruent. And then when you see the word regular in front of a polygon, like a regular triangle or a regular quadrilateral, know that all sides and angles are congruent. So in other words, it's going to be both equilateral and equiangular. The word that you're going to see used a lot is the word regular. Pretty good. Next one, Polygon Exterior Angles Theorem. This states that the sum of the measures of the exterior angles of a convex polygon, one at each vertex, is 360. So no special formula here, no n minus 2 times 180. Every single polygon, the exterior angles always add up to be 360. So if you get a question on your quiz and I say, what do the exterior angles of a decagon equal? You should automatically know without doing any math that it's 360. If it's a hundredagon, they're all going to add up to be 360. So this is an easy question to answer as long as you memorize that always all exterior angles of a polygon are going to add to 360. And the way that you create those exterior angles is you would continue the side, and the exterior angles are all here in red. And there's only one exterior angle at each vertex. Okay, so it doesn't matter what type of polygon it is, it's always going to add up to be 360. Now, we're going to take that n minus 2 times 180, and let's say instead they ask you how much is one angle in a triangle. So again, let's do the formula. So let's say I said, how much is one angle in a regular triangle? So we would do number of sides is 3 minus 2. And then once we do that, we divide it by the number of sides. So 3 minus 2 is 1. 1 times 180 is 180. And then I divide that by 3. And this tells me that each angle in that regular triangle is going to be 60 degrees. Again, this should all be a review of middle school. Somewhere in your middle school, 6th grade, 7th grade, 8th grade math, you should have learned all this. So this should be a nice little review. Let's classify the polygons here by the number of sides, and then tell me, is the polygon equilateral, meaning all sides are the same, equiangular, meaning all angles the same, or is it regular, because it's both? So we have to look at the congruency marks. So in figure A, notice all of these sides, 1, 2, 3, 4, 5, 6, all have the same congruency mark. So far, I see that all the sides are congruent. Now let's go through, and I've counted that there's 6 of them. Now let me go back and check out all 6 angles. Notice all 6 angles have the same congruency mark. So this tells me that all angles are also congruent, making this a regular 6-sided figure, which is a hexagon. So the word regular in front tells me that all sides are the same and all angles are the same. Let's try B. Notice this one. If I start looking at my sides, let's count them. 1, 2, 3, 4. It's a 4-sided figure, but none of the sides are congruent together. I have opposite ones that are congruent, but I do not have any angles that are all the same. So this would just be a quadrilateral. It's not regular, and it's not equilateral, and it's not equiangular. It's just a quadrilateral. we're going to learn coming up that this is actually a parallelogram. And let's look at figure C. Start looking at all of these angles here and all of the sides. So let's start counting. I've got maybe I'll do highlight. I'll do it in blue. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 11, 12. I've got 12 sides. So the name for a 12-sided figure is a dodecagon. I can see that all the sides are congruent. And now notice it's not convex. So the words only work when it's convex. This is actually concave. See how this one's caving in? So the only thing I can say here about this figure is it's a dodecagon and it's equilateral. Yes?
Wait, what does it mean when it's convex?
Convex means that none of the sides cave in. Like if I were to draw diagonals here, when I draw this diagonal here to here, you see it's outside. When it's convex, the diagonals are always inside. See how none of my sides look like they're caving in? So the two types were concave and convex. All right, let's try some examples. Now we're just going to practice finding the sums of the angles and the exterior angles. Now, when you're taking the test and the quiz for this chapter, watch for the key words. If it says the sum, then you're only using for the interior the n-2 times 180. You're not dividing it by n when it says sum. But if it said each angle, that's when we have to divide. So here we need to know that a heptagon has 7 sides because that's the n value. So again, I'm using n-2 times 180. I'm going to do 7 minus 2 times 180. 7 minus 2 is 5 times 180. And the answer here for part A is 900 degrees. I do 180 times 5, and I get 900. Now, the sum of the exteriors, no math here, you're just memorizing that no matter what type of polygon, it's always 360 degrees. Let's see. Now we're going to do a 17agon. I'm still using the same formula. This time I don't have to memorize a special word. I'm still doing the n-2 times 180. So I do 17 minus 2, which is 15, times 180. And I get 0.09. 2,700. So all 17 angles, when I add them up, will add up to be 2,700. For the exterior angles, you memorize that no matter how big that polygon is, all exterior angles will always add up to be 360 degrees. Now, you should also be able to work backwards from the formula. So let's go ahead and instead of them giving us the number of sides, they're going to give us the sum of the angles. So let's try the next example. So for this one, they want us to find how many sides are in the polygon. Now, in the past, when I've given a question like this on the test, Students think that they can guess and test and start plugging in values of n so that they can get to the number. It doesn't work. The numbers that we end up picking for the questions, if you don't know how to work backwards with the formula, you're going to waste too much time on this type of question. So watch the process, because more than likely you're going to get a question like this. So we're going to use the same formula. We're using n minus 2 times 180, but now instead of them giving me a value of n, they're telling me what this formula equals, and it equals 900. Now, I can solve this two ways, and I'm going to show you both ways, depending on how your Algebra 1 teacher taught this, or even your pre-algebra teacher. So we can do two things here. We can either, and probably the most common thing that you probably saw was distributive. So you can distribute the 180 to the n and distribute it to the 2. And now I have a nice simple two-step equation where I'm going to add 360. I get 180n is equal to 1,260. Divide by 180, and n equals 7. So the number of sides in my polygon is 7, making this polygon a heptagon. Now, the other way that you could do this is I could have just, instead of distributing, divide both sides by 180 to get rid of that, and then I get n minus 2 equals 5. Add 2, and n equals 7. So you could solve it either way. They both work. But be able to work backwards of the formula where they give you the sum and you have to find the n value. We have one last slide. And we're going to do several different polygons. This time, they're asking us to find each angle. So this is where I have to divide. So again, be very careful when you take the test. If it says sum, we just use this formula here, n minus 2 times 180. But when they say to find each interior angle, this is where we'll divide by n. And that's what we're going to do on the next slide. Anybody still need this one? Okay, let's try the next one. So it says two parts here. Find each interior angle and each exterior angle. So for this part, the each interior, I'm using the formula n minus 2 times 180 divided by n. For the exterior angle, each one, remember, it always adds up to be 360. So here, if I want to find what 1 is, I divide it by the number of sides. So we're going to be dividing on these. So here, we need to know, for the first one, part A, how many sides are in a quadrilateral. And we know that there are 4 sides in a quadrilateral. So what I'm going to do here is 4. Well, let me do it in red so it matches what I underlined. 4 minus 2 times 180 divided by 4. I can do the parentheses. Now, if you want to simplify before you divide, you could do that. Or you could just multiply and then divide and get 90. But if you prefer to do things like, I'm going to simplify this, make this a 1, make this a 2, and then just now divide 180 by 2, you can do things like that, especially if you're not using a calculator. So for the interior angle, so each interior is going to be 90 degrees. Each exterior, I'm going to take 360, divide it by 4, which is what I just did, and the exterior angles also are going to each be 90 degrees. For the octagon, this is where you need to know that an octagon has 8 sides. So your n value here is going to be 8. So we could do the exterior first since I've got the blue here. I'm going to do 360 divided by 8. When I do that, I get 4, 32, 45. So each exterior of an octagon is going to be 45 degrees. For the interior of the octagon, this is where we're going to do 8 minus 2 times 180 divided by 8. 8 minus 2 is 6. Divide by 8. Now, if you're not using a calculator, you might want to try to simplify before you multiply. I could reduce the 6/8 and make this 3/4. And then if you want to multiply what's left, you can do that. You could even simplify the 180 and the 4. 4 actually goes in here 45 times. And then 3 times 45 is going to give me 135. And that's what each interior angle adds up is equal to. If you'd rather just do the 180 times 6, get that answer, and then divide that by 8, you can do that as well. So whatever you prefer to do, you would get 1080 and then divide it by 8, and then you get the 135. For the 15agon, for the exterior angles, we're just going to take the 360. We're going to divide it by 15. And 15 will go into 36 twice. And 15 goes into 60 4 times. So each exterior angle of the 15agon is 24 degrees. For the interior, you're doing 15 minus 2 times 180 divided by 15. 15 minus 2 is 13 times 180 divided by 15. So again, if you don't like to simplify, if I multiply that top, I get 2,340 divided by 15, and each angle is 156 degrees. And these are the interior angles. And the last one is a 20agon. Actually, that should have been in red. No, I should have done this in red. So now the 20agon, we'll do the exterior first. 360 divided by 20. I could simplify this, and then 36 divided by 2. Each angle is 18 degrees. For the interior, 20 minus 2 times 180 divided by 20. 20 minus 2 is 18. Again, if you want to simplify, you can. If not, you're multiplying 18 times 180. I get 3,240 over 20. Divide that, and each interior angle is 162 degrees. Now, one key thing to note, once you get these interior and exterior angle together, they're sitting on a straight line. So if you were to go back and add up the interior plus the exterior, They should add up to be 180. If they don't, you've made a careless mistake somewhere. Now, if you want to see, like here, I could have simplified just to show you if you're not ever using a calculator. Let's say this is an SAT and you can't use calculators. You could simplify things, like I could do 20 goes into 180 9 times, and then I'm just left with multiplying 18 times 9. And I can still get the 162. So you can choose whichever number you want to simplify with, especially if you're ever not using a calculator. Any questions? So that is it. So again, you probably did this in middle school. This could be a nice little refresher for some of you. If you didn't see it, here you go. Here are the notes and how to do it. So you do have a homework assignment. It's due tomorrow. And then tomorrow we're going to move on to 7-2.